Hello everyone, I hope you're all doing well. Today we're going to solve question 3 of chapter 2 physics 1. In part A, we are asked to obtain the position, velocity and acceleration of the particle at t equals to 3 seconds. Part A. For the position, the question has actually given us the relationship between the position and the time, which is actually x equals to 12t squared minus 2t to the power of 3. So for the position, all we have to do is to just plug t as 3 and obtain x at t equals to 3. So at t equals to 3, we would have x3 equals to 12 times 3 squared minus 2 times 3 cubed, which is going to be equal to 54 meters. That's it. For the position, all we had to do is to just plug the time into our equation. What about for the velocity? How should we obtain the velocity at t equals to 3? For velocity, first we have to actually obtain the equation of velocity with respect to time. And considering the fact that the velocity can be obtained by taking the time derivative of the position, we can say that v by definition equals to dx over dt. So if I take the derivative of this with respect to t, we will have 2 times 12t minus 2 times 3t squared. This is the equation for velocity. Now, at t equals to 3, we would have v3 equals to, plugging 3 into this equation, we would have 2 times 12 times 3 minus, 2 times 3 is 6, and then 3 squared, which would give us 18 meters per second. We've obtained the position, velocity, and the next part of the question is asking us to obtain the acceleration at t equals to 3. Again, by definition, acceleration is defined as the derivative of the velocity with respect to time. Now, so in order to obtain the acceleration, again, acceleration equals to the derivative of the velocity equation with respect to time. Okay, now all we have to do here is to just take the derivative of this equation with respect to time, or we can actually say that it's the second derivative of the position with respect to time, which is going to be equal to, taking the derivative of this, it's going to make this 2 times 12, which is 24, and then that's it, minus 6 times 2t. This is going to be our equation for acceleration. So again, at t equals to 3, we would have a3 equals to 24 minus 2 times 6 is 12, and then t is going to be just 3, which is going to give us minus 12 meters per square seconds. Okay, make sure that you write the units correctly. Velocity is meters per second, acceleration is meter per squares of second. Okay, that's just part A, super easy. For part B, we're asked to obtain the maximum position coordinate reached by the particle, and we're asked to obtain the time for which that occurs. So how to obtain the maximum position? Okay, so all we have to do is to just maximize this. We have a function of position with respect to time. We have to figure out what is the maximum value of this function. Going back to calculus, if you should remember that in order to obtain the maximum of a function which is differentiable, all you need to do is to obtain t so that dx, the first derivative, is equal to 0, and this is part B. And the second derivative of the function, which is in our case is x, with respect to time, or t, is negative. So these are the two requirements in order for your function to be in the maximum position. Okay, now looking at dx over dt, what is the physical meaning of dx over dt? Well, by now you should know that dx over dt is just the definition of velocity. So this is just velocity, and the second derivative of x with respect to time is, by definition, is acceleration. So in other words, in order for us to satisfy, reach to the maximum, all we have to do is to find t for which v equals to 0, the velocity equals to 0, and the acceleration a is negative. Okay, so these are the two conditions that we have to satisfy in order to find the maximum value of x. V equals to 0. Let's look at the first condition. We have a function of v with respect to t. So all we have to do is to obtain figure out where this becomes 0. So v has to be equal to 0. Then using this equation, we have 2 times 12, which is 24t, minus 6t squared equals to 0. Okay, now if I factor out t here, I would have t times 24 minus 60 equals to 0. And we know that if the product of two numbers is 0, then that means that at least one of these two has to be 0. So in order for this to be 0, either t has to be equal to 0 or 24 minus 60 has to be 0. Well, t equal to 0 is so one possible solution, and if I just rearrange this, I would have t equals to 4 seconds. This is my second possible point that I have to check. Now this is just satisfying the first condition. Now we have to check if these points actually satisfy the second condition, which is the second derivative has to be less than 0, or acceleration less than 0. So for at t equals to 0, we can obtain the acceleration as a0, t equals to 0, a0 equals to, if I plug 0 here, I would get 24. At t equals to 0, a acceleration is 24 meters per square seconds, which is positive. So this is not satisfying the second condition, which means that t equals to 0 is not giving me the maximum value of x. So t equals to 0 is not a possibility. Now let's look at t equals to 4. At t equals to 4, the acceleration, if I plug it into my acceleration equation, a4 would be equal to 24 minus 2 times 6 is 12, and then t equals to 4, so times 4, which is going to be equal to negative 24 meters per square seconds. There we go. We've obtained the acceleration to be negative, so a4 is negative. Good. Now we have a4 negative, and we know that at t equals to 4, velocity is 0. So we have also v4 equal to 0. So at t equals to 4, both of these conditions are met, meaning that t equals to 4 will give us the maximum value of x. Now if I plug it here, then at t equals to 4, I would have x4 equals to, if I just plug it here, it would be 20, here, the equation for the position, it's like 12 times 4 squared minus 2 times 4 cubed, which if you plug into your calculator, you will obtain 64 meters. So the answer for part B is that at t equals to 4, we will reach to our maximum value of the position, and the position is actually 64. That's it. Just using calculus in this part. And for part C, we are asked to obtain the average acceleration of the particle between t equals to 0 and t equals to 3. So part C, we are asked to obtain the average acceleration from t equals to 0 to 3 seconds. Okay, by definition, the average acceleration, a average, equals to delta v, the change in velocity during that time interval, divided by the duration of the time interval. So in our case, it would turn into velocity at t equals to 3, at v equals to 3, minus velocity at t equals to 0, divided by the time duration, which is 3 minus 0. So all I have to do to obtain the average acceleration from t equals to 0 to t equals to 3 is to obtain velocity at t equals to 3 and subtract it from v equals to 0, v0, sorry, which is going to be equal to, at v equals to 3, if I look at here, I've already obtained v3, which is 18. And for v0, which means that t equals to 0, if I plug it here, I will see that v will become 0 because I have t here and I have t here. So if I plug 0 to be t, like 0 in t, it would make this whole thing 0. So it's going to be 18 minus 0 divided by 3, which is going to be 6 meters per square second. And that's it.